So let's move on to stoichiometry and the limiting reagent. So stoichiometry, it's a hard word to pronounce, but in technical terms, it's the relationship between reactants and/or products in a reaction used to determine quantitative data. It's a bit hard to wrap your head around, but let's do an example first. So here we have a reaction between iron and chlorine gas to make iron 3 chloride. An example here says how much iron 3 chloride can be isolated if 23 grams of chlorine gas react with excess iron. It's important that we understand that we have excess iron here. We'll come back to that in a second, but just note that. So first thing we need to do is determine the moles of chlorine gas. So we can do that. Remember our formula, moles equals mass divided by molar mass. So remember chlorine gas is diatomic, so it's 2 chlorine atoms, which adds up to a molar mass of 70.9. So we get 0.324 moles of chlorine gas. So now we can determine the moles of iron 3 chloride using stoichiometry. So this is all it means. We have the moles of chlorine gas, 0.324 we just calculated. We need to use that to somehow get into moles of iron 3 chloride. So there exists a relationship between chlorine gas and iron 3 chloride, where for every 3 molecules of chlorine gas we use, we make 2 molecules of iron 3 chloride. So we can just use this ratio right here to switch our terms. So this causes the chlorine gas to be crossed out when we put it in the bottom and introduces iron 3 chloride in the top. So essentially all we're doing is multiplying by 2 and dividing by 3 to get 0.216 moles of iron 3 chloride. That's not what the question was asking. It just wants to know how much iron 3 chloride that is. So we need to change that back into mass. So we can do that by just rearranging our formula for moles. So mass equals moles times the molar mass. We have the moles, 0.216 moles, we just got that, and the molar mass of iron 3 chloride, which you can again get from the periodic table, is 162.2 grams per mole. When we work it all out, we get 35 grams of iron 3 chloride being produced. So the limiting reagent, also known as the limiting reactant, is by definition the reactant that's used up entirely in a chemical reaction. So a chemical reaction is always going to be a reaction between 1, sometimes 2, sometimes 3, or however many chemicals to form other chemicals. But if you have a reaction between 2 or more chemicals, one of them is probably going to run out before the others. The one that runs out first, the one that's used up entirely, is called the limiting reagent, because as soon as that's used up, you can't keep going. So imagine you're trying to build a car, and you can build a car, and it's as easy as attaching 4 tires to a car body. So if you have 1 car body, you need 4 tires to make 1 car. But imagine now you have 3 car bodies and 10 tires. Well, if you do the math, then you can only make 2 cars. You'll have 2 tires that are unused. That would mean that the number of car bodies is your limiting reagent. So we can identify the limiting reagent through some math. So here I wrote an equation of lithium nitride reacting with water to give us ammonia, NH3, and lithium hydroxide. So I'm telling you that you have 4.87 grams of lithium nitride and 5.80 grams of water. So first thing we need to do is figure out the moles of each of these, because you can't do chemistry in mass, you need to do it in moles. So the moles of lithium nitride can be determined by, again, our moles to mass formula. So right here, we get 0.14 moles of lithium nitride. Using that, we can again change that into the moles of ammonia by using our ratio. So if we look here, we see that we need 1 molecule of lithium nitride to give us 1 molecule of ammonia. So 1-to-1 ratio means the number of moles of lithium nitride used gives us the number of moles of ammonia produced. Over here, let's use water now. So I told you have 5.80 grams of water. So that in moles is just 0.322 moles. If we take that and we convert it, notice how you need 3 molecules of water to get 1 molecule of ammonia. So for every 3 moles of water, it can only give you 1 mole of ammonia. So that just gives us this ratio. So these 2 cross out, and you're left with 0.107 moles of ammonia. So which one will give you less ammonia? This will give you less ammonia, so this must be the limiting reagent. I only picked ammonia as an example. You could have just as easily picked lithium hydroxide and done the math from there. It'll still have given you this as the limiting reagent, water. The one thing to keep in mind is whatever you're comparing, it needs to be the same on both sides. So in each case, I compared ammonia. You can't compare ammonia in one case and then lithium hydroxide in the other. It needs to be for the same product.